Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 7th, 2025, just yesterday. The striking result is that this paper's trainable agent beats strong baselines, with average accuracy gains of 14.9% on search, 14.0% on agentic tasks, 14.5% on mathematical tasks, and 4.1% on scientific tasks, even surpassing GPT-4o. The paper is titled, In the Flow Agentic System Optimization for Effective Planning and Tool Use, and the implications for model training are quite significant. In short, a modular planner trained in the loop with flow-based group-refined policy optimization aligns local decisions to global success and improves tool reliability. Also, the authors shared a GitHub repo. You'll find the AGENTFLOW codebase with a modular agent package, quickstart.py for instant inference, setup scripts, and Flow-GRPO training pipelines. It includes data prep utilities, TMU-X-based training and serving, benchmark runners, config files, and examples for plugging in your own models and tools. So, Figure 1 summarizes the headline message. Tuning the planner in the flow with Flow-GRPO yields sizable accuracy gains across many tasks. The left radar chart contrasts the untuned and tuned systems, which makes the overall jump in capability visually clear. On the right, small bar charts compare against well-known baselines, and the red bars consistently lead because planning improves and tool calls fail less often. Alright, Figure 2 shows how the agent runs in the flow, which means the planner is trained during live multi-turn interaction, so it adapts to real tool outputs. The left panel outlines 4 cooperating modules that pass information through an evolving memory to produce an answer. The right panel details one turn. The planner proposes an action, the executor runs a tool, the verifier checks it, and the memory updates. This cycle repeats to support long horizon reasoning. Well, with Figure 2 covering the in the flow loop, Figure 4 shows how the planner gets optimized through Flow-GRPO. The left block takes the query, memory, and tools into the policy model, which stays close to a reference model via KL control. The middle panel stacks multiple rollouts, so each turn sees full memory. The right side converts final outcomes into shared rewards and computes group-normalized advantages, stabilizing single-turn updates. With the optimization mechanics established, Table 1 reports head-to-head accuracy on search-intensive and agentic tasks. Agentic tasks mean multi-turn problems that require choosing and calling tools, so coordination quality matters. The 2 bottom rows show the tuned system leading the pack. The green delta columns mark gains over each baseline, highlighting consistent margins. Notably, the Flow-GRPO variant posts the highest averages because the planner aligns its turn-level choices with final success. Okay, Table 2 extends the comparison to mathematical and scientific reasoning. It shows the tuned agent leading the rows, with green delta columns marking consistent gains over each baseline. On math, the Flow-GRPO variant averages about 52%, which edges past much larger systems like GPT-4o because the planner stays aligned to final outcomes. On science, the average reaches about 64%, and tool use appears steadier with fewer failed calls. Wrapping up, 2 takeaways stand out. Training the planner in the flow with Flow-GRPO turns sparse, long horizon rewards into stable single-turn learning, and a modular agent built around this approach beats larger models while cutting tool call failures. The broader implication is clear. On policy, live loop training should extend across modules. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.